Alrighty, welcome back to the stream. And hello, Min. How are you doing today? Yes, indeed. We're going to do a little bit of BlockBall playing. And by a little bit of playing, I mean bashing my head against a wall until I get this code to work properly. And by bashing my head against this wall, I mean actually bashing my head against the wall, because we're going to be working on collision today. At least that's the plan. So... yeah. So... collision is something I have been waiting to do until I felt like I was more comfortable with the game and the coding and all that stuff. But I think it's about time we actually see about dealing with that. And I'm going to make two quick notes right now, actually. So right now, collision is done on a very simple case of if it hits the paddle, it basically just inverts the X coordinate and sort of bounces it off in a radial direction out from this center point. So if the ball impacts right here, center point is there, it'll just go straight out. If the ball impacts here, center point is there, it'll go like that direction. That's how collision currently works. And I want to adjust that a little bit. So my idea was to have the entire face of this thing be some sort of like plane, and then you have, when the ball comes in there, it always reflects off at an angle that's mirroring what it came in at. The trick there being, of course, that there's other issues, so I may have to keep this original form in here as well. But that can be dealt with later. Different collision bits for different situations, right? Anyway. Let's get into it. Oh yeah, also, since last time, I believe I added this prior. I can check my source stuff, actually. Let's see. History. Yeah, okay. So, the most recent things I've done is, let's see, 21st, so last week would have been the 14th. Yeah, so I have script settings, has the extra functions now. Script default settings default was missing for some reason, and then I re-added that, and I added a default button to the settings. So if I go to settings now, there's a little default button there. All that does is it just, if there is a settings INI file, it just deletes it and sort of resets it with all the default settings. So that's all that does. Now, here's the collision stuff. So when I was looking around for any bits of information on this, close that for the time being, I found this script, and there's actually a website called gmlscripts.com, which has a lot of these things on it. Now, gmlscripts.com, hold on a second, let me just do this. gmlscripts.com has a lot of stuff on here, and this one actually has a example of how this works. So I'm just going to capture this real quick. Check this out. This is where I found the script, and it sort of gives you a little bit of a thing on how it works. The purpose of the script is to determine what direction the sprite of an instance is facing at a particular point on or near the sprite, i.e. a 2D analog of a surface normal. It does this by sampling an area around a given point. As each point is sampled, if there's no collision, a vector is generated from the center of the sample, or the sample point. These vectors are summed to produce an overall direction vector pointing away from any detected surface within the sampled area. Shows you right there what's going on. Basically, it takes a point of impact right here and does an area around it and says, okay, where are all the things that there is a sprite or collision box? Detects all those, says, okay, those don't count, add the rest of these up, and because these ones counteract each other, so like this one counteract this direction and that direction, you just get a resulting vector that points in that direction or whatever. And you have all these things pointing together, and you get a final vector that points off in this direction. And that gives you a normal vector, effectively. And you can see an example here where, for example, all these surfaces are calculated out. This is like collision math, and it tells you like, oh, look, the normal vector here is pointing in that direction and all that way. And you can actually spawn a ball by clicking, and it'll bounce off using that math, which is pretty funky. These do the same thing. Those edges, for some reason, aren't quite working right, but it does sort of do what it needs to do. So this is basically what I want to use, and I want to sort of muck around with to get what I need out of it. So the entire script has been copied over here, and we're going to just take a look at this. And I agree that using it for collision stuff here is probably the best way to do it. So create script, call it script. Oh. We're just going to get rid of this and replace it with a code block. Now, the main thing I'm doing here is I am not going to be copying this wholesale because, one, I need to figure out exactly how it works, which doesn't do much if I don't understand, like, the basic bits of it. And two, I might need to make adjustments to it to get it to work. Also, let me just double check something right here because I forgot to check this beforehand. Let's see. Which one's which? Dot product is right. Dot product is like the projection of one vector onto another vector. So that's not what I want. Whereas cross product is cross product isn't quite what I want either, is it? Yeah, no, cross product is perpendicular to the other two products. So that's not what I want either. So which function would I want to do across that to mirror it? What's the actual math to do that? Reflection vector. Let's see. Vector representing normal of a surface. Oh, right. Before I forgot, this is also the, I almost totally forgot. This is the ambient playlist from StreamBeats. Let's see. So you have D and normal, and you get R. R is equal to D minus 2 D dot N times N. Where D dot N is the dot product and N must be normalized. Right, that makes sense. You need a normal vector. Yeah, okay, that makes sense. Okay. So I'm just gonna real quickly then make a note here for collision. Okay. Reflected vector equals it's an incident. Yes, the incident vector. it's R is equal to D dot D minus 2 D dot N. Okay, now what's the thing for dot product? It's just dot underscore product. Okay, that works too. So dot underscore product is x1, x2, x1, y1, x2, y2. We need to get the vector of the player to the enemy. We'll then get the dot product of these vectors. Vector normal from the enemy, and then vector of the player to the enemy. Get the dot product of these vectors. Ah, I see. So this would be effectively determining a vision cone. So it's dot product x1, y1, x2, y2. Okay, I guess that'll have to do. Okay. Back to the script. So, what does this take in? It doesn't take in anything. So var xx, var yy, obj red. Oh, I see. So you have to use them. You have to use a function collision normal x1 y1 object radius resolution. Which are set up here. So if argument count is greater than 3, rad is equal to argument 3. Argument count is greater than 4. This is unnecessary because we already know how to do this. So this might be an older thing. So it'd be like function, collision, normal. And it would be x1, y1, obj, rad, res, like this. So this would be obj, then rad is equal to 4, res is equal to 1. I believe I'm doing that right. Not the one I wanted. God, which one was it that I did this in? Scaling? No, it wasn't scaling. Resolution. No. Was it player input? Yes, it was. So that's what you work with there. You got x1, y1, object, red is 4, resolution is 1, which basically takes care of this nonsense. So those lines don't even need to exist anymore. Nor do these. Well, yeah, you know what? Let's just do this. So var radius resol. There we go. Actually, can I just do argument 3 and 4? Does that work? I think that works. Then those go away. Still. Okay. Now, var nx, var ny. If collision circle xx, yy, radius object, blah, true, true. Variable j equals res, j is less than or equal to rad, blah, blah, for that. If, okay, this is a lot of nested stuff right here, which is doing all the work. Okay, so how about, first, let's find out what collision circle is. Collision circle. Collision circle creates a circular zone of radius given by the user, which is 4 in this case, around the points x1, y1, and then checks that zone for collision with any instance of the object specified by the argument object. So, wait. Okay, wait. So, creates a circular zone around the radius given by the user around the points x1, y1, and then checks that zone for collision with any instance of the object specified by the argument. This check can either be precise or not, but for precise collisions to be enabled, the object or instance that you're checking for must also have precise collisions enabled for their sprite. If not, the default check is based on bounding boxes. Now the blue ones do not have precise bounding box. Okay. So, X and Y are the points of the object to do the checking, right? Which I believe this would actually be run by the ball in that case. I believe that's what this should actually be doing. That actually makes more sense. So, My original plan... Here, my original plan here... Let me just... window capture. Paint. Right. So the original plan I had was, let's say this is the paddle right here, and this is the ball. If the ball's coming in at an angle or whatever, right, it'll detect the normal and then bounce off, sort of in a mirror point to that. That's what you want to have happen when you're doing some kind of thing there. But what I also wanted to do was, instead of just colliding with the paddle, I was gonna have like a sort of collision object that would actually hold the math and do everything there. Which would be like a trapezoidal shaped thing, and that's actually what the ball is colliding against. When the ball collides against the paddle, what it actually hits is this object right here, and that contains like the normal vector protruding out from it and everything else, and that does all the math. But what this is actually doing is it's removing the need for that, and it's actually running all the collision math based on the ball itself. So the ball on collision, when the ball collides with this, it sends out the detection for everything around it for collision types. And it says, okay, so this area is being collided against. The rest of these points add together, and that gives you the normal vector pointing out, and then I can do the math based on that to get the reflection vector. This is how punch lasers work, isn't it? Because there's a thing in, I believe it was it Arkham? Hold on, where did punch lasers originate from? Punch laser. No, not a whole punch laser. I mean, punch lasers in video games. Oh, was it Last of Us? Yeah, okay, it was Last of Us. So in original Last of Us, one of the developers at one point mentioned that, like, the way they did, like, takedowns specific to terrain kind of things. Like, Sifu did it more recently that I was playing on stream. But, like, there's specific takedowns for depending on what state the enemy is in and specific terrain nearby. So, for example, if you're next to a wall, the guy will punch a dude into a wall and knock him out that way. But if you're next to a ledge, he'll, like, push him over the ledge or something, right? So what that's doing, I think, is on contact, when your fist contacts the enemy's face, it sends out a collision sphere, which goes, okay, what's the closest thing? It goes, this is the closest thing right here. That's a ledge type object. And then it activates that and throws them off the ledge. Which means I could actually use this same trick to replicate that. If I wanted to, let's take an example that exists. Let's take a Hotline Miami, right? Here's a little person right here. Let's say in Hotline Miami, you've got a window here. That's a window. Don't question it. You've got a door over here. And you've got, I don't know, a chair over here or something. Like that, right? You got a chair there, and this is your little dude. When you punch a guy, let's say you punch a dude right here, you got your fist collision coming in, you get an active hitbox, and you have a collision circle that activates. And what you could actually do is you could have the collision circle start at, like, the lowest radius and keep expanding out until it hits the nearest, like, active object, which would be this window. Instead of an object index, you simply use instance ID to check for a specific instance or the instance keywords, all or other, depending on the event and current code scope. Ooh. Oh, okay. So I could actually just use, instead of checking for specific paddle or whatever, I can actually just check all. So anytime it happens, or other, which means that if I did other, it would hit specifically anything that isn't another ball, but if I had multi-ball in play, it would actually, if I did all, it would just do it every time I impact something, which could be really good. But anyway, yeah, if you do this, you just do collision circles that keep going out, and as soon as it hits an object, it pulls that object's ID and says, okay, what object type is that? That's a door type, which means we're going to chuck this dude through the door and open the door. Like, that's what I think you could do with that. Oh, that's so cool! Ah! New technology and new tricks being found every day. Anyway, technology. Finding out something new every day. So, collision circle. Object, asset, or instance ID. So I think what I'm going to do is I'm going to set object to all by default. So if I don't specify anything, it'll just by itself determine, as long as it's contacting something, do a radius 4 pixel check, resolution 1 pixel, define whatever else. So hit the collision circle, XX, YY. So XX, YY are the X coordinate, and the Y coordinate, which is going to be its own. Those are going to be its own X and Y coordinates. So I could actually put self.x and self.y. Because just by running this by default, I could have it just. I could just have it run by default. Just put in the regular function collision normal, just like this. So I just run collision normal, and then it just runs it like that. Right? This is nice though. I didn't know about argument blah. That's actually quite helpful. Okay, so it runs that. X coordinate, Y coordinate. The radius is 4. It's just default 4 pixel. I don't quite understand what the resolution is, but we'll figure that out. Object is all in this case, and then the true there is pixel perfect collisions, which means it's using, if I go back to sprites and such. So if I go back to sprites here, for example, or rather, do I want to do sprite or object? Object. If I go back to the paddle object, for example, here, the collision mask is same as the sprite, and the sprite is not what I want to do. The sprite has a precise collision mask, which means that it's locked to whatever the shape of this is. If I make it like a diamond shape, it'll be diamond shaped. If I make it spherical, it'll be spherical. Or circular, whatever. So that's the important thing there. Alright. Anyway, I want this to be true, because that means it'll work if I do something like rotate the paddle, or make it a weird shape paddle, or something like that, so it'll actually do what I want. Let's see. Now the second one there, the other true is... not me. Whether the calling instance, if relevant, should be excluded or not. So I probably want to exclude that, which is why it's set to true. If I don't exclude that, do I want to? Hold on. I might not care. I don't know. That's something to fiddle around with. I don't know if I want this to be true or not right now. Anyway, if what is this? Wait, why does this return? Returns instance ID or none. So that'll return the ID for the instance. So yeah, I do want to exclude myself then, because that would include the ball in the check, which I definitely do not want to do. Okay, so for variable j is equal to resolution. Starts at 1. J is less than radius. J plus equal resolution. Okay, so resolution is basically why doesn't it start at 0? I guess it's like 1 point away. Okay, so for variable I is less than radius, I plus 1. Okay, so this is moving it distance-wise out, I think. If point distance 0, 0, ij is less than or equal to rad. Hold on, what is point distance? Okay, point distance returns the length of a vector formed by the specified components x1, y1, and x2, y2. Why is it 0, 0? Okay, so let me write down what I think is going on here, right? Okay, so collision circle generates collision zone. Wait, no, because this is returning a true value. I'm just cleaning a little bit of this annoying stuff up. Okay, I think that's... Go. Okay, now it's clean. Sort of. I feel like this isn't quite as optimized as it could be. So, what is this returning exactly? So it's telling me it's running collision circle, right? Collision circle either returns instance ID or no. Code above will check the circular area with a 20 pixel radius for collision with object cursor. If there is one, it will set the image index the object running the code to 1, but there is not, it will set the index the object to 0. Okay, so basically this is determining if there is something to collide with within that radius. Still be able to use this idea I had, honestly. Okay, so this thing runs, let's see. If there's a object in collision radius. So that's in the entirety of the collision radius, too. The entire collision radius determines this. J is equal to resolution, so J starts at 1. J equals 1 to 4, increasing by 1. For I, if the point distance from 0 to ij is less than or equal to the radius, which is 4, okay, so the weird part is here, why is it 0, 0 on the point distance? Or rather, what is that trying to do? Oh, I see now. I see. I understand now. Okay, I see. Also, I'm going to be right back. I need to check if the air conditioner is working. I'll be back in a moment. shockingly, the house is not 75 degrees yet. Which is why I set the air conditioner to kick on at. Which is, that's, okay. I'm just surprised, really. Okay, so I see what this is doing. So what this is doing is it's not... Okay. Move this over a little bit. What this is doing is it's actually... It's not creating vectors from the ball out to wherever. What it's actually doing is it's creating vectors from 0, 0 to each of the points, like, at whatever distance away from origin. And then it's applying this to the ball. So it's doing the vectors from there, effectively. It's just adding pre-generated vectors to that. Which I guess makes sense. Good way to think about it, right? So what actually I think you should do here I think what this actually should be is instead of doing this, what it should actually be, just in my personal opinion, is do var, let's say, obj lid is equal to that. What's your problem? That's the whatever. And then you do if obj lid is not equal new one. And then you go from there. And the reason why I do that is because at this point here, object here is effectively just going to be pulling from all, because that's what I set object to be. Like, I could set it to be block or wall or whatever, but let me think here. So obj college. Okay, so obj collid. If obj collid is not equal to no one, which means that there is actually something, because collision circle will return instance ID or no one. So doing this means that it has returned an instance ID. There is an instance that is currently detecting as a collider object. So, you know what, at the same time, I mean, yeah, okay, so this still works. This is still fine. All this does is give me a little bit more granularity, because what I could actually do is I could implement this script in each of the collision events for the ball. So if I go to the ball right here, I've got collision paddle, score, and wall here. I'm not going to do anything with score because that does everything it needs. I don't need to reflect anything off of that. I just need to delete the ball. Object paddle and object wall. So in case of object paddle, what I can do is I can get the stuff from there. Like, all this stuff is pretty much the same. But this part right here is what needs to be changed around. So I can execute code here. And let's see here. This is gonna be like old stuff, or let's say I have two settings, right? I have a setting for if, let's do like a if global, like, it would be something like if global simple collision is on, I could just make a new variable for that and just say, like, okay, if we're doing simple collisions, do this one, else use this fancy code that I'm making up, which is actually just going to be collision normal. It would be like a and then object, so object paddle. And then that's going to return the vector, and then I would just multiply that times so what was it again? It was going to be this. So this equals d minus 2 times dot product 2 times dot product, and it would have to return the normal vector. And it's okay. So there's more stuff that goes into it than this, basically. But we're getting there. We're getting there. Slowly, very, very slowly, but surely. Which is why it's important I understand how this thing works and break it apart properly. Does point direction return a variable or a vector? Or what does it return? Returns a real value. I could get rid of this. So, let me see here. How do I add vectors in this thing? I think there's a bit more stuff I could do with this to make it do exactly what I want. So basically what it's doing right now is it's doing what I was working with before, where it's running this stuff and then it's getting a point direction here, which I'm using, which I could use like right here. So effectively I would run the script right at this spot, get the point direction, and then invert it by 180 or something. But I think I can do better. Maybe. So what I would do here is... So if object collide does not equal no one, which means there is an object colliding. Let's see. So this isn't terrible, honestly. What it's basically doing is... It's creating these, like, fake vectors here, which... Okay, so basically, what this is just here to do is to make sure it's not going outside the radius. That's all it's doing. So you don't wind up with something that goes too big and covers too much area. That makes sense. And these two are incrementing up each section of the resulting vectors that are being checked. If collision point... Oh, if not collision point... So if the collision point does not detect the object type there, then you add up stuff to get the vector in that area. And it's basically spidering out in radial direction each time. Okay, I see. So these should be changed. This is going to be changed to optical lid. Just because that's what it would be. The reason I did that is because, technically speaking, this will collide with... If there's two different objects next to it, it will collide with the same thing. Like, or rather, it won't collide with the same things, but if, like, I'm in a corner, for example, paddles here, balls here, walls here, it'll actually collide with both of them simultaneously. Whereas if I do it this way, it'll only collide with one at the same time, which is better for running in a situation where I'm not running it on the step, I'm running it on the actual collision, which is what I want to keep track of. Okay, and also, just if I did run it on step generically, it would only determine the first thing it collides with instead of everything nearby. So just as an example here, if I just ran this as an example here, yeah, I figured as much. Let's do cogs. what's the problem there? Use function script name for a variable using pop. Oh, that's why. Right, because these are reflected. Right, that makes sense. Alright, so the reason... So, like, the main reason I want to point out, like, is if I hit it in the corner right up there, for example... I'm not going to be able to do this properly. Like, if I hit it in the corner, like, right where the paddle is right now, if I get it close enough, it actually will detect both the wall and the paddle as being collision objects, when it really should only be detecting the paddle. So what I want to do is effectively lock into the first thing it hits and use that to determine the collision alone. If in the instance it actually hits both things simultaneously, then we have an issue. But that's like a 1 in a million chance. But we'll see, I suppose. Okay. So the collision is dealt with. Blah 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 blah. Variable point distance. Okay. Part of the problem I had actually with trying to figure this out is I was always thinking in terms of the thing being collided against. So the wall had to have the collider object, or the paddle had to have the collider object, instead of the ball having the collider object, which made more sense. Or the ball having the collider map. Instead of having... The main reason was because I thought I would have to have the normal variable baked into the paddle or the wall or whatever in order to have the ball properly bounce off of it. But it does make more sense if the ball just dynamically... Well, it only makes sense because I know about this collision point thing now. If I didn't know about the collision circle... Actually, collision circle and collision point are different. It's collision point. Collision point checks the point specified by the argument x1, y1 for a collision with any instance of the object specified by the argument object. This check can be either precise or not, but for precise collisions to be enabled, the object or instance that you're checking for must also have precise collisions and blah blah. Okay, yeah. Okay. Okay, returns instance ID or no one. Okay. C, okay. I think I get it. So Yeah, so the collision circle just determines, is there a collision inside the circle? If it does, then it goes, okay, that's the thing we're looking for. Find the collision, right? Find the object that's we're colliding against. Then for this vector size, it'll find out first if that vector is within the radius of the circle, and then it'll do a little bit of math here. If X and Y are larger, so that would be down right, does not hit anything, then you add it to the vector. If you do X positive, Y negative, so up, yeah, X positive, Y negative. If it hits something, then it doesn't add the vector. If it does, it adds the vector. If you do X negative, Y negative, which is top left, like let's say we're hitting left side paddle, which it would be doing. It'll hit that, it'll go, okay, we're hitting that, which means don't subtract this one, or don't add it, I should say. And then if you're doing this one down here, it says don't add it. So you do that. I want to return a vector, here's the thing. So let me be right back. Okay, so I think very simple what I want to do here. All I want to do is I want to return... I want to return a vector. So I think what I'd want to do here, let me actually double check return. Let me see if this has any, Okay, so if you use return, anything else will not run. Got it. How do I return a vector? Would I have to? I probably have to declare the vector immediately. Yeah, okay. So what I probably want to do here is, let's call, var normal 0 equals an x, var normal 1 and y. I guess you can't return that. So I guess it'll probably have to be, this probably just have to be this. Like that. So normal 0 and normal 1. They start off at 0. So I don't need to do this. I don't need to have this bit at all. I mean, it returns a null value, but it's not really what I need. The dot product of a 0 vector is going to be 0, so it doesn't really change anything. Okay, so just take that out, return normal. And we're also going to do this normal. Add those two there. There you go. So it goes back and overrides it. I don't even need this else, do I? Yeah, I could just do this. I don't need to clear it up here. This if statement is fine. I mean, technically speaking, I could run the entire thing by its... Like, I don't even need this if. Technically speaking. But having the if statement there makes it so it doesn't run constantly if I want to run it on the step value. If I do, on the other hand, if I run it on the collision, I don't need to even have that if statement. Like this entire part, this can just go. It doesn't matter. Because I know I'm colliding with something. It literally will only trigger on a collision. So if I'm running it on, I'll keep it there. Because I want to keep it in case I do decide to run it on step instead. But it's actually not useful. I don't actually need that. So as for the rest of this, these two are just incrementing values in order to check space around the point. This is just a check to make sure that the resulting thing is not out of scope for the radius provided. And this here is the actual math, and it's actually just very simplified. It doesn't have any of the funky variable stuff or anything. It's basically just adding values to the vector variable, to the vector point, based on what it should be attached to. So that should do it. So, that'll return a normal vector, which is good. Okay, so leave that for the time being. So here. Let's just do this in the paddle real quick. So, var norm equal to collision normal, self x, self y, paddle, radius, resolution. That looks fine. Alright, so, now this is actually going to be slightly tricky. Let me just also do that. This. I have to get my current. So what I need is this. Okay, so I have Can I get the current direction vector? I don't need this. I need... let's add another script right here. We're gonna add another function right here. We're just gonna call it function. Direction vector. And what that's gonna do is that's gonna tell you what the current vector is for yourself. So it's gonna be self. And it's gonna be self. How do I actually get that? Direction. Built-in variable. What is direction variable? Let's see here. Direction. Real, single precision floating point value. Zero being right, 90 up, 820 left, and 270 being down. Oh, also, this needs to be normalized. How do you normalize a variable? I need a vector function. So let's normalize. Normalize vector. Dot product normalized. Normalized dot product has been corrected in such ways to bring the return value to the range of -1 and 1. Okay, I found a thing here which just has so according to this, it would be dsign. Okay, so it's var dir x equal to equals direction. Okay, so apparently that should be that. Why is dir y giving me this? Just do this. Right, I can skip a step. How did I... There. Okay, now... I guess this would be self-dot. Like that. So that'll return a direction vector for whatever I'm looking at. Okay, so... var ref is equal to dir minus 2 times dot product. Okay. And then, let's try it. That's on paddle collision, so let's see how this works. I'm expecting something to break terribly. Yeah, there we go. That's what I thought. Illegal array use is the issue I have here. Illegal array use. Maybe it's because it's timesing there? Or, you know what? It might actually be because of ref 0 equals 0. Ref 1 0. Let's try that. Maybe it's because I'm not treating it as a... this isn't going to work either, come to think of it. Yeah, it's not going to work either. Because direction is not an array. I set point direction? Is that a vector? Let me try this here. Do we do that and I set point direction down here. Call it a ref 0. See, that works. Nope. Illegal array use. I'm not sure what the illegal array use is. Let me just see here. If I turn that off, what's going to happen? What happens right now if I do this? Nothing. It's completely frozen in place. That makes sense. Another illegal array use. Let's see if this works. Illegal array use. Yeah, okay, that figures because it's just bouncing it off that way. Or rather, it was bouncing it towards 0, 0. Okay, let's do this real quick. Ugh. Let's try this. Easy enough to clip it out, thankfully. Okay, so on collision with the paddle. This is now a point direction, and I don't really know how to deal with this in this instance. Collision normal has been determined right there, right? So what do I do with this? Let's see what just happens if I did this, right? Let's see. How do I set... What other point direction functions are there? How do I set point direction? Direction equals point direction. Oh, that's it. Okay, that makes sense. Let's try that. What's it gonna do? Nothing. What if I do this? Nothing. Norm times direction. Nothing. So if I do this, I think it'll just probably give me the same thing because the direction variable's not changing. Yeah. Same deal. So how do I set the direction variable? Oh. Well, that's incredibly handy, huh? So I don't need to convert it directly. I can just do that. Oh, hey, how about that? That's insanely useful, actually. So direction is point direction, yada yada. Where X and Y are itself, and then other X and Y are set. And then set direction variable direction plus equal 180. There we go. Let's see if that works. See if that does anything. Really. Sort of. Okay, now why is it sticking there is my question. So why is it sticking on that one specifically? How the fuck did that get in my room? Hold on a second. Okay, so, this is where my inexperience with this is showing. What I'm trying to do is I'm trying to take this thing here, right, and output what is it actually outputting? Let me take that example, right? Let's go back up to here. So what it's actually calculating is... Okay, so it's not actually, like, applying the thing to the collision spot. What it's actually doing is it's generating a point direction directly away from wherever it is. Which is actually fine, because that is what I need. I'm curious, what else is in here? Also, what is this license thing? Cannot claim that you wrote the original software. Alter source version must be plain marked as such. Cannot be removed or altered. Yeah, okay. I'll have to use that at some point. I wonder what other scripts there are. I don't know, I'll do like this. I don't know, like, it's helpful. Don't get me wrong, this website is very helpful, but also, like, this is a very basic thing. It's just, like... It's hard to... Like, basically the only thing I need to do for this one, I could just rewrite the whole thing myself. Only thing I would really need is this part here. Like, this part and this part were the two missing points. Like, I will include the script and all that, or the license and all that, but it's just... I feel like, I don't know, attaching a license to that seems a little weird just because of how minimal it all is. Like, attaching a license to something like the window stuff, which lets me actually change the window border because that's a DLL and it's a whole thing, that makes sense, sure. But, like, this is... Effectively, this is just a couple lines of code that are changing things. Like, I don't know, is there anything fancier here? Motion predict. This is a whole thing, but again, it's all like very minimal. It's very strange. Whatever. It's not a big deal. I mean, hell, I could potentially put my thing on here, and then anyone who writes code similar to mine just has to use my use the license from now. That's, or somebody else could just copy it and throw it up there under their own thing. I don't know. It seems a little awkward. Like basically the thing that's bothering me about this is that this could have taken the form of a tutorial, but instead it's a thing you can copy paste that fills out the script for you. That part's weird. Why did it do that? I get why it would do that if I spawned the ball in there. But it getting stuck in there from the outside is strange. Or like over there, it just got stuck somehow. How did that work? Why did that happen? I do like how you can actually download that. That's nice. Alright. So, like I was saying, what it does is it takes the point direction and generates a point direction, which is effectively... Point direction is basically what? Basically just the vector magnitude and... No, it is the vector, effectively, but it's not... It's just like a weird... Excuse me. What? Okay, what is the point direction? Point direction returns the direction of a vector formed by the specified coordinates. So this coordinates in relation to the fixed XY coordinates of the room. For example, in the image below, if we want the direction from the player's ship position to the enemy position, we can fire a missile. We use this function. Point direction x1, y1, x2, y2 returns real. So does point direction return a variable then? Or does it return... What does it actually return? No, it returns an angle. That's what it returns. So that's what it returns, an angle. That's what it is. All right, so actually, let's test that. Let's check that. Let's go back here and object ball. We're gonna have okay, it creates norm. It creates a variable norm. So we are gonna go to object ball. We're going to add a UI event here. Five, and let's call it let's see how that works. not set before reading it. Figures. Right, create. Let's bring new value here. Norm. Oh god, I fucked it up, right. Why isn't it printing? Let's do function. Collision normal. Blank, blank, obj paddle, blank, blank. Okay, let's try that out. Why isn't it printing the value? Oh. Oh. Let's do that. Huh. Yeah, I think, okay, I'm pretty sure it's the angle. I'm pretty sure it's the angle from whatever to the second thing. So if we're looking at my picture of reflection, okay, so I'm trying to think here. If I do it this way, like this is the thing, right? So you come in here, it hits this point here, it determines a normal here, which is the angle relative to what? Okay, so okay, wait. Is it 0, 90, 180? Hold on. Okay, so I think this image is actually what's throwing me off when I think about this. So what it is... Because I've been thinking about, like, the block comes in, right? Hits the paddle. And then it comes at an angle. Normal. Bounces off like this. But I think it's actually being calculated out like this. Where this is the impact surface. This is the normal vector. But this is the actual vector of impact. Even though the block is over here on this part. This is pointing, let's say, up 90 degrees. This is pointing, I don't know. Technically, I suppose it would be actually all the way around like this. So this would be like 300 or something. I don't know. And then this one is 60. So what I actually need to do is I need to get this vector here on the other side of the normal. So that would be 90 minus 100, or 90 minus 300 is... Let's see, 90 minus 300. Wrong button. I don't need the calculator for 90 minus 300. I need the calculator for the part that comes after that. Okay, so 90 minus 300 is negative 210. Okay, so hold on. What are the actual angles in GameMaker? Which one's up? Okay, right is 0, up is 90. So 0, 90, 180, 270. So this would actually be 270 plus negative 210. 60? No, because that's not what I want. So it'd be 270 plus 210 is that. Minus 360 is 120. Which would be here, roughly. Plus 90. Give me this. And multiply that by 180 to get that. So I'd actually just probably be better off just doing minus 90. There. Okay. So it's going to be 90 minus 90 minus angle, which will get me negative 210 in this case. Negative 210. Actually, what's 210 plus? Wait. 150. Okay, so 90 minus Okay, so let's say this is 300 degrees. So 90 minus 300 degrees is negative 210, which translates out to 150 degrees, which is over here. Plus 90? Or minus 90? Hold on. A minus angle. Minus 90. So, no, that would just be the angle again. And that's not even the correct angle. It would be the normal in this case. So it would be normal minus point direction. Okay, I gotta do some checks here. I gotta do some like checks. Okay, let's do some math just to make sure I've got this correct. Make a new Google sheet here. Okay. I feel like there's probably a much easier way to do this, but I'm doing it this way. Okay. So let's go. Normal angle. Incident angle. Expected output. And then calc. Alright, so the normal angle, let's set it to pure straight left is gonna be no, let's say we're hitting it to the right. Let's say we're hitting it to the right. We're hitting the left paddle, which means normal angle is 0. Incident angle is going to be 45. So it's coming in from the top right. Which means the expected output is going to be negative 45, because it's going to be on the other side of that, which would be 36. What's 36 minus 45? 315. 315. And the important part here is you've got to also make it so that it always works. 315 slash negative 45. There we go. All right, so calculation would just be normal angle minus incident angle. And that gives you negative 45. Okay, so let's set it to 90. Incident angle is going to be 45 again. Expected output. So this is pointing up, coming from the top right. Expected output would be going to the top left, which would be an angle of 135. And of course, that does not transfer over anymore, because it's not quite right. So this would have to be something like, can't be 90 plus 45. I mean, of course, I could do a bunch of conditional stuff, but that's not going to be good. So I gotta find the... Okay, so if I do instant angle minus normal angle, maybe? No, because then that would give me 45 in the first instance. I'm gonna look it up. There's gotta be an equation for this. Angle of reflection equals the angle of incidence. Yes, but that doesn't work on a coordinate plane. To reflect over the x-axis, simply multiply the y-coordinate of the point by -1. Use notation prime. Indicate that. It's not helpful. Aren't quite right. Okay, let me think here. Gotta be a way to do it as an equation without doing ifs. So it would have to be something like... So it had to be something like, say it's this and there. The angle from here to here, and the angle from here to here. So these two angles are the same. But I can't get this angle directly. Not without doing some actual kind of comparative logic here. So this is an angle of x. So the known angle here, or rather this angle here, so the difference between this point direction and here that's 270 minus angle. So there's 270 here. So if I do 360 degrees minus that angle, give me this minus the normal. $360 minus that angle gives me this entire area. Minus 90 degrees would give me this. But then if I flip it around, so instead I'm going like this. This is where the reflection should be. 360 gives me this. Minus 90 would give me that. So is it just 270 minus that? $270. No, it'd be 360 minus the normal minus your point direction, but I don't know if that works in all cases. But for example, let's do okay, so let's do this. It would be 360 minus normal minus instant angle gives you 315. Okay. That gives you 225 for this one. 225 is 180 plus, or 180 plus the thing, which is kind of correct, but backwards. Maybe that's it. Let's try it. 360 minus minus normal minus incident. 160 minus normal minus direction. I doubt this is gonna work. No. Alright, so what about if we throw on the plus minus plus equal 180 thing there? Oh, it's working. Here, did I do it? Did I actually do it? I think I actually did it. I did it! I figured it out. I did it! It's doing it! It's doing it! Look, it's doing it! Regardless of where it hits on the thing, it's bouncing off at the normal. Okay, now that's... Oh, hey, that kind of fixed a little bit. Okay, now that's weird. Why is it stopping it? That should be bouncing up. Or at like an angle off to the side there. So that tells me the math is not quite... Oh, hey, that actually kind of worked. That worked. Okay, now that should be bouncing off. Why isn't it? Like, the normal according to this thing should be... It's gonna, like... Let's say it goes like this, right? It should be going, like, in this direction, roughly. Probably mostly down, but it should be going off, like, there. Like, push up, it's kind of doing that. So it's not perfect. Not perfect, but it is getting there. Okay, so this is good. Now, the fact that this is fixed up, let's call it fixed up with big air quotes there, is actually very good because it means now I can start doing some dumb stuff. For example, let's just go to controls here. Or actually, no. Let's go to Game Master. Master game. I'm gonna create step. I'm gonna want which one? 0? Yeah. Right, game objects. Paddle. You know, actually, you know what? Put in the step instead. Applies to... Let's set it by 1 degree, so it'll rotate rather slowly. And -1 degree for pedal 2. So why not? This is why I wanted to have this collision set up. Because now, assuming things are working properly, which they don't seem to be doing. Oh, I'm stuck in a wall! I'm stuck in a wall! That's awkward. So what I'm trying to get it to do there we go. Is I'm trying to get it to bounce off in odd directions based on the angle of this thing, which it doesn't seem to be doing. Unfortunately. Or if it is doing it, I'm very unlucky and it's not doing it quite right. Yeah, no, it's not doing it. It's just bouncing off as if it was, it's like bouncing off directly normal to it, despite the fact that it should be bouncing off at weird angles because of the math. Like, that one should have been bouncing down. So I wonder, did I have paddle set to precise? Mode, automatic, full image, precise. Precise for per frame, maybe? Aha! Yes! Okay, some weird stuff still happening there. It's not quite doing it right. It's definitely not doing it right still. It's been stuck in the ball's been stuck now. That should have bounced up. That should bounce down. That should also bounce down. So it's not perfect. Still also clip into the walls, which is very odd. That's better, though. No, still no. All that seems to be doing is changing, like, the hit area. It's not actually changing the angle it's being deflected off of, which is something I really need here. Well, that's something at least. Anyway, this is good. This is good. I've got something to work with now. Although I would like to know why it's not quite right. Like, why isn't it doing a proper... Oh, wait, I bet I know why. I bet I know why. That's probably why. I forgot to turn the rotation back on. Did I delete the rotation? Oh, it was here. Yeah, I must delete the rotations. I don't think I did that. Not quite. Not quite. No. Still no. Still no. It does it only when it's like trapped inside of it, which is very strange. You know what? Let's see something here. Let's see something. If instead of running it here, I run this on the step event. So it's bouncing off of itself there is the problem. That might be part of it. This is still only reacting to object paddle. Why? Why is it doing that? Ah, that's why. This point direction is getting returned regardless. That's why. awful. Okay, so it's kind of doing it. Kind of doing it, but not really. It's gonna be a minute. Okay. I don't know where the failure is here. I have a couple guesses. It's sitting in front of the computer, but the actual problem with the code, I don't really know what's going on. Like, I don't know if it's a problem with the angle calculations. I don't know if it's a problem with, like, point direction stuff. I don't know what's up. So, I gotta figure that out. I suppose the easiest way to do it would just be to create a collision testing room or something. There might even be a much more efficient way to do this that I can just figure out eventually, but right now I just have no idea. At least this doesn't seem impossible, thankfully. Sorry that this isn't, like, exciting. It used to be really fun to do this stuff because I would always have, like, a good breakthrough, but this is much more complicated now. There's just so many moving parts that it becomes much harder to, like, parse what's actually wrong and what I need to fix. And then I just keep leaving stuff for homework because, like, it takes multiple days to work through each of these problems. I got no idea. I have no idea. The good thing is that nothing has been really removed. I can revert everything back to its previous state in just a couple clicks, because all I need to do is just disable this and re-enable this. And voila! Game is basically back to normal. Oh, I gotta turn off the rotations too. So like, voila, game's back to normal state. I got no idea. I am completely out of ideas here. I'm gonna be real. So I've got two things I'm going to try and do for homework, besides fix the resolution settings, which are still an issue. Those are also going to be something I'm going to have to take down to like the base level and see if I can figure out what the best way to do it would be. I need to figure out first if there's an easier and simpler way to do this. That does seem like a pretty good way to do it, but there might be a better way. And then I've got to also figure out why it's not giving me the angles that I want. I have a feeling I know why. But I need to figure out how to get what I want out of it. That's the other thing. I need to figure out how to get what I want, how to deal with it. All that stuff needs to be dealt with. Alright, anyway, I'm gonna leave that there. Also, it's starting to get hotter outside, which is fun. It's, looks like 87 outside? Woohoo! Fun stuff. Not too bad inside, though. So far. It takes a minute for the heat to penetrate into the walls of the house, as it were. Yeah, I'm gonna work on this off screen. That's all I got. Like, I guess I gotta just plug away at it. We're at the part of this where my lack of expertise and knowledge of what's going on here is starting to show. Although, I will say, learning about this, fantastic. I love this. This is great. Now I can see, okay, this is what goes on there. This is how the code works. Call user events, blah, blah, blah. Like, all this is great. This is fantastic. That is by far the biggest great feature that I found. Now, instead of saying, like, what is set instance variable, I can do this and go set instance variable with blank, with instance paddle p, whatever, set y equal plus equal move. Like, that's it. That's all I had to do. So that'll make learning it much easier, at least. Like, that's a feature. Like, seriously, like, GameMaker Studio isn't the most robust game platform, but it is the best one to learn with, because these blocks make things much easier. And then once you're starting to, like, graduate, you can go, okay, set instance variable is this. That's what it's referring to. Assign variable. Assign variable. I mean, I kind of knew what that one was. Call user events. If enter is equal to 1, then you assign variable execute code, which is just the text thing I put there. If variable GS menu selector selected is GS menu save, then you do this. If it's sound effects, it does that. It's so much better. So much better. It just makes it so easy. I really, that single feature makes it way better in my opinion. Anyway, I'm gonna try and figure out what's going on with this stuff. Like, I don't like doing the work off screen because, one, it's more time spent doing it just in my off time, and two, it kind of takes away from the point of these streams, which is sort of learn how to do it along with the stream. But at the same time, if it's just a lot of me, like, trying different numbers in and seeing which one of them finally works, that's not exactly the most thrilling thing to watch, especially if I'm doing it in code, because the blocks are easy to see as well. Anyway, I'm just gonna leave that there for now. So I'll be back with this next week, hopefully with something fixed. If not the collisions, at least the resolution, I hope. Otherwise, I'll be back tomorrow with more Pathfinder Wrath of the Righteous, and I may play some Prodigal later. Maybe, we'll see. I might just take a break. I might die due to air conditioning failure. It's very unclear at the moment. We'll see. Anyway, I'll be back at some point. Thanks for stopping by. Enjoy the rest of your day, evening, night, what have you. Once again, you've been listening to StreamBeats. The music is the ambient playlist. I'm just feeling tired, man. I need to take a break. I'll see you next time.